Hearty welcome to the learners. I am Dr.S.SUVITHA, working as Associate Professor in the EC Department of SA Engineering College. On behalf of our college, SA Engineering College and Department of ECE, I welcome all the learners to the GATE coaching video session, topic on signals and system, in which we will be discussing today's convolution. So this is our department vision and mission. Now we'll enter into the topic convolution. Convolution is a process by which we can obtain the output of any system. So convolution is a process by which an input interacts with an LTI system to produce an output. So we all know signal is being classified into two types, continuous time and discrete time. That is the basic classification. So here the convolution also we have two. Convolution integral is for the continuous time and then convolution sum is for the discrete time. Here it is just the representation of the system. Okay, so input is x of t, we have a LTI system, and then we will be getting as a output as y of t, which is the convolution of input and your LTI system response, which we call it as x of t convolution h of t. So in the frequency domain it could be represented as x of omega, y of omega equal to x of omega into h of omega. It is just the representation of a system which performs convolution. So convolution integral, as I told, it is represented as y of t is equal to x of t convolution h of t. This is the formula to perform convolution, which is integral minus infinity to plus infinity x of tau, h of t minus tau into d tau. The convolution is commutation, hence we can represent in this way also. So integral minus infinity to plus infinity h of tau, x of t minus tau into d tau. Okay, let us take h of t will represent as an impulse response. Okay, so what is impulse response? Impulse response is the output response when your input is said to be del of t, which is impulse, unit impulse. So hence it is represented as, so when you substitute x of t as del of t, y of t become h of t. So h of t is equal to del of t into h of t. So it is just mere substituting it. So the integration becomes mere substitution. Hence we will be getting your output as h of t. When h of t is 0, we call that system. Okay, condition is h of t is 0. For t less than 0, we call the system as causal. So next is convolution sum. Before we have seen convolution integral, which is for continuous time. Convolution sum is for discrete time. So now it is just the representation of the system. So input is x of n, h of n gives the impulse response, the output y of n is denoted as x of n convolution h of n. X of n is the input sequence, h of n is the impulse sequence, y of n we call it as output sequence. Hence the formula to find convolution sum is summation k equal to minus infinity to plus infinity x of k, h of n minus k. Hence this is also commutative, hence you can represent in either of this way. So the methods to perform convolution sum is graphical method, tabulation method, matrix method, whereas convolution integral we can do in graphical method, formula method. So convolution integral we have two types, graphical, formula, and then here convolution sum we have three methods, graphical method, tabulation method and matrix method. So this is the steps to perform convolution. So it applicable to both convolution sum and convolution integral. So the steps is, first step is folding. This is the operation, set of operation which are used to perform convolution. So first is folding, second is shifting, third one is multiplication, and the last one is integration if the case is convolution integral. Okay, so or else we have to summate everything for convolution sum. That alone, the step 4 alone differs for convolution integral and convolution sum. So hence one of the sequence we have to keep it as such, like x1 of t we are keeping it as x1 of tau, whereas the second signal we are making it as x2 of tau, and then we are folding the sequence, hence we will be getting x2 of tau, and then the folder signal has to be shifted, hence we will be getting x2 of minus of tau minus t, and then it has to be multiplied with the another signal which is x1 of tau, and then last it has to be integrated. So this is the procedure or the steps to perform convolution. The last step alone differs with respect to integral, convolution integral and convolution sum. Now we'll take up one problem and I'll tell the procedure to solve it, right? So here we have taken unit step as both the signal, that is x of t is also unit step signal, h of t is also unit step signal. Hence output you will be getting by convolving x of t and h of t, hence y of t is equal to u of t, convolution u of t. Okay, we need to apply formula. So substituting it in formula, you will be getting u of tau, u of t minus tau. Okay, first we need to plot it, hence this gives you u of tau, and this is folding operation by which you will be getting u of t minus tau, and then folded signal has to be shifted. But in this case shifting we have two conditions. Okay, so the shifting particular delay, either it is less than 0 or greater than 0, so we are going to consider both of the cases. So t less than 0, here is the signal. Okay, t greater than 0, this is the signal. Now we need to compare the shifted signal with the another signal, which means the first signal, which is the original, has to be compared with the shifted signal, and we need to calculate the overlapping period. So here you could see there is no overlapping region. Hence if you are going to integrate that, since there is no overlapping, the integration becomes 0 because we doesn't have any overlapping region. So signal won't be there. So the integration is perfectly 0. And then we have to, so the condition less than t equal to 0, we won't get any integration because there is no overlapping period. So the answer is 0. Whereas for the condition where t greater than 0, we have a signal like this. Now you compare both of this. So we have a overlapping signal from 0 to t. Hence the convolution integrates, convolution integral has the lower limit as 0 and the upper limit as t. Hence you could see here. So we have, by substituting that, you will be having a condition like 0 to t dt, because the amplitude is 1, simply we will be getting dt for the condition t greater than 0. So integrating 1, we will be getting t. Hence this is nothing but the ramp signal, we all know. So convolving unit step, 2 unit step will result in ramp signal. This is the most important result. Okay, that is important, you can make a note of it. Yeah, next comes the properties of convolution. So we have, here I have highlighted only the very important properties. So I have highlighted only 4 properties. First is commutative. So x1 of t convolution x2 of t is equal to x2 of t convolution x1 of t. This I already mentioned. The next one is associative. So x1 of t convolution x2 of t convolution x3 of t equal to x1 of t convolution x2 of t convolution x3 of t, which means you can, if 3 signals are there, first you can do 2 convolution between any 2, and then at last the resultant has to be convolved with another signal. So anyway the result will be same. So that is associative. Next is distributive. So here comes the addition of 2 signals, hence it has to be performed individually. So you will be getting the same answer. And the most important result is said to be, important property is said to be impulse response. If you are convolving your any signal with the impulse, here I have taken a shifted impulse, hence you will be getting the original signal but with the shifted response. Okay, so x of t convolution del of t minus t1 equal to x of t minus t1. So let us consider the shift is 0. If you are considering the shift is 0, here we will be getting x of t into del of t, which results in x of t. This is an example just for the sake of understanding I have mentioned here. So let us take u of t minus 1, which is the unit step shifted signal, and then the del of t plus 2. Here the answer is supposed to be u of this t, which is t plus 2, and then here we have one more shift which is minus 1. The resultant is supposed to be u of t plus 1. Yeah. So the continuation of the previous slide, here we are having convolution of standard signals. Okay, so there in the previous slide we have seen the convolution between unit step and impulse signal, but here instead of unit we will be taking a simple x of t as an input. So x of t convolution del of t, just substitute in the formula, so that answer will be x of t. So convolving any signal with del of t results in the same signal. This is again one of the very important thing, kindly make a note of it. And then the signal with the shifted impulse results in the same signal but shifted version. This is again another important result. So continuing the convolution of the standard signals, here we are having one more example, convolution of two rectangular pulses with same width, okay, equal duration. So you could see x1 of t as a width of 0 to t, same way x2 of t again as 0 of t, width as 0 of t, hence convolving these two results in triangular signal. So triangular signal of width 2t and its amplitude is a1 plus a2, sorry, a1 into a2 into t. So this is again one of the very important result. Convolution of two rectangular pulses of equal duration will be a triangle. One more we have, so convolution of again two rectangular pulses, but here the width differs. So first signal has got the width as 0 to t1 and the second has got 0 to t2, so unequal duration. So if it is unequal, we are getting a trapezoid. So this is trapezoid, so which has got the width of 0 to t1 plus t2 and whose amplitude is a1 into a2 into t1. Yeah, now let us take one example. So let y of n denotes the convolution of h of n is equal to 1 by 2 power n u of n and g of n is causal sequence. If y of 0 is 1 and y of 1 is 1 by 2, then g of 1 equals. So for solving this particular problem, you need to go with matrix method, because I already mentioned for convolution we have three methods. Okay, so here we are going to choose matrix method. So you can very well solve the answer. Okay, now we'll see the solution of it. So the answer is 0. Okay, the solution is yes, matrix method. So h of n, as when you substitute the value, you'll be getting the sequence as 1, 1 by 2, 1 by 4, whereas g of n, we doesn't know the signal, hence I have taken as g of 0, g of 1, g of 2. When you multiply, you'll be getting this particular, and diagonally you divide the sequence, hence the first y of 0 is g of 0, and then y of 1 is nothing but the addition of g of 1 plus g of 0 by 2 by substituting y of 0, g of 0, equating it, which is equivalent to 1. So hence I am using that result over here, hence I will be getting 1 by 2. So in the question they have given as y of 1 is equal to r. From this we can know that g of 1 is simply 0. This is how you need to solve your questions. Yeah, this is the practice. Okay, so here I am just highlighted some of the problems. You can take it as a assignment or a practice one. So how is discrete time convolution represented? So we all know x of n, convolution h of n. So what are the tools used in graphical method? I have already mentioned, which is plotting, folding, shifting, multiplication and addition. Likewise you can solve your problem. Okay, so these are all the problem, which is very basic problems only I have mentioned over here. You can practice all these things. So thank you. We'll all meet up in the next session. Thank you all.